Hello, welcome to video round 2. In this video, we're looking at how to solve some of the more difficult first principles questions. So I'm going to go through 3 examples. The difficult ones involve fractions, they involve surds, and lastly, they involve fractions and surds. Because I need to lay my screen flat to write on it, you guys get to look at a tree for a bit. Enjoy. Alright, so the first example we are considering is f of x equals 3 on x squared. Now, before you even start doing anything with first principles questions, it's worth doing it off in the margin or on scrap paper, just reminding yourself of what the answer should be. So f dash x, well, we'll start with just f of x. F of x is really 3x to the minus 2. Therefore, f dash x is going to be minus 6x to the minus 3. All right, that is where we're going. It's really nice to have that off to the side to let yourself know that that is the end goal, the end target. If we don't end up there, then something's gone wrong. All right, so the first step in any of these, after that, finding the actual answer, is to write out the formula. So in this case, the formula is f dash x equals the limit as h approaches 0 of f of x plus h, take f of x on h. Alright, now we know this from the previous video that this is the first line. After this we can drop off the f dash x, but we need to keep the limit of h approaches 0, and now we make the substitution. So, equals lim h approaches 0, make the substitution. So in this case, x plus h is being substituted into that equation. So it's 3 over x plus h squared, take the original equation, 3 over x squared, all over h. Alright, now we've got to the bit where, to be honest, it's a little nasty. So here's the strategy. After we've earned our first mark by writing the formula and substituting into the formula, because we've got a fraction, generally our advice is fractions are miserable, so we're going to get rid of them. We are going to multiply by 1 in order to achieve a common denominator. Then we're going to combine the fractions and finally keep, change, flip. Now, multiplying by 1 is a trick that we come up with and use all the time. The important thing is, when we multiply by 1, we don't have to do it to both sides of the equations, because multiplying by 1 doesn't actually change anything. Now, I think it's worth me going through here and sort of explaining my logic with real numbers before we get back to the more algebraic version. So, for example, if I had a half plus 2/3, you guys would know that you need a common denominator. The process of getting a common denominator actually involves multiplying by 1. So I would multiply by 1 by doing this. Both of these are just 1. And by multiplying by 1, 3 on 3 is 1, 2 on 2 is 1, I get 3 on 6 plus 4 on 6. After that, I've got a common denominator. I can add the tops together, leaving the bottoms the same, is 7 on 6. Don't know why I wrote 4. Alright, that multiplying by 1 is what we're using here to combine this pair of fractions at the top. So we need a common denominator to aim for. Now, the easiest way to get a common denominator to aim for is to multiply them both together. So here, the 2 and the 3 multiply together to get the 6, so I know that 6 is a good common denominator to aim for. So here, I'm going to aim for a common denominator by multiplying by 1. Alright. So, once again, limit has to stay there. Lim h approaches 0. Then I have 3 on x plus h squared, and I'm going to multiply top and bottom here by x squared over x squared, minus 3 on x squared, and I'm going to multiply top and bottom here by x plus h squared over x plus h squared, all over h. So what I've done is I've multiplied by 1, exactly the same as I did with the real numbers here. And that will give us a common denominator. Lim h approaches 0 of 3x squared over x squared x plus h squared, forgive my handwriting, minus 3 lots of x plus h squared over x squared x plus h squared all over h. Don't let the h approach 0 drift onto the top of the fraction. It's meant to live just out the front. Alright, so now we have common denominator we can combine. Combining looks like this. Lim h approaches 0 of 3x squared take 3x plus h squared over x squared bracket x plus h squared over h. So I've combined that top fraction there into this one here. Alright, nice. Now we've combined the fractions. I eventually want to look at factorizing out an h. So there's a couple of options to go for here, but generally I want to leave this denominator alone and I want to expand and simplify out the top. And my goal is to get some sort of 8 hanging on its own up here, which I can then cancel like that. It's a bit like if I had 10 on 2 on 5. I can cancel this 5 with a 5 from there, and it leaves me with just 1. Sorry, it leaves me with just 2. 2 on 2, which is 1. I need to factor out that h and then remove it. It'll become a little clearer when I actually show you what I'm aiming for. So equals lim h approaches 0 of 3x squared take. Now this you may want to do in a couple of steps. Definitely worth reminding yourself that x plus h squared is x squared plus 2xh plus h squared. That combo is really important. And then, of course, with the minus 3 out the front, minus 3 hits all of them. So we've got minus 3x squared minus 6xh minus 3h squared. All right, and that whole thing is over x squared, x plus h squared, and it's all over h. All right, let's tidy up the top now. So common terms or like terms, they can go. Excellent. So if they go, I have lim h approaches 0, and then I have minus 6x, and I'm actually not going to write the h for a second, minus 3h. I'm going to factor out h. What I've done there is I recognize there is an h there and an h squared there, so I can pull that out to be a common factor of h there. That will then multiply back in to get me the original, but I actually like it factored out. If you want, you can factor it out the front. People like doing it there, but I put it there. Both are fine. Now this point here, I'm going to cancel those two. And showing that cancellation earns us our next mark. This would probably be a 4 marker, and right now we've gone most of the way to the marks. Alright, so that cancellation is required before we let h go towards 0. If we let h go towards 0 and we still have this h down the bottom here, then we lose a mark because we're effectively dividing by 0. But now it's gone, it's cancelled out, we can let h go towards 0. So let h approach 0. You don't have to write that, but it's good to sort of show you know what's happening. As h approaches 0, then what we're going to get is minus 6x, well, minus 3 lots of 0, so that's nothing, over x squared bracket x squared x plus 0 squared, which is really equal to minus 6x over x to the power of 4. Because x plus 0 is just x, all squared is x squared times x squared is x to the power of 4. This is then minus 6x to the minus 3, because you've got a power of 1 at the top and 4 at the bottom, cancels out to minus 3, which is, well, that is our answer. F dash x is minus 6x to the minus 3, which is exactly what we had at the start. Cool. So, the important thing here is we are substituting into the equation, multiplying by 1 to get a common denominator, combining the fractions, factoring out h, which is there. We didn't actually do it here. I was just hoping to, like showing you where it was going. And then letting h go towards 0, and it simplifies down dramatically. All right, next one, surds. So, surds are miserable. Get rid of them. And the strategy here will be multiplied by 1 again, but this time the 1 will look different. Then combine and simplify. All right, once again, first step is actually find the answer. Let's just remind ourselves that this is actually x to the 3 on 2, and therefore f dash x will be 3 on 2 x to the half, or might come out as 3 on 2 root x. So that's our answer. It's where we're going eventually. What we need to do now is write the formula, substitute in the formula, we get our first mark. So formula, f dash x is equal to the limit as h approaches 0 of f of x plus h, take f of x on h. Right, then substitute. Lim h approaches 0 of, well, x plus h root x plus h minus x root x over h. Are we still recording? All right, sorry. All right, here, multiply by 1, in this case by the conjugate. All right, we want to, just remembering the overall goal here, is basically combine this top to the point where we can pull an h out. Now, what happens on the bottom is not as important, because we've already got an h here that we can cancel with, so we're going to multiply by 1. Here, multiplying by 1 looks rather odd. So R1 will look like x plus h root x plus h plus x root x over x plus h plus x root x. Now, clearly what I've done is I've just repeated this entire top thing, but I've changed the sign. Multiplying by a sign change is called the conjugate. You will have done this in surds in year 10 or year 11, and you might recognize this from rationalizing the denominator. Here we're going to rationalize the numerator, that one on top, and then put it together. All right, so where to from here? Equals lim h approaches 0 of. Now, you might remember that this comes from a plus b, a take b, that goes to a squared take b squared. That's what we're relying on here. And it doesn't matter if we get the signs the other way around. In this case, it's a take and a plus. We still end up there. So this bit here is our a, that bit is our b. What we're aiming for on the top is that the first one squared take the second one squared. So in this case, it's just going to be x plus h squared x plus h. Note that the square root and the square root will just combine to a single term of it, and that x plus h squared, take x squared x. Now clearly there's some simplifying to do, but I'm simply showing you that a squared would look like this portion here, and b squared is that portion there. All right, on the bottom, h bracket x plus h root x plus h plus x root x. On the bottom, I'm not going to distribute that h in. The reason I'm not going to distribute it in is because I want a factor of h to cancel out. So actually, the h hanging there is just fine. Like, that is sweet. We can leave it there, no worries. All right, so we now need to get to the numerator, this top section, to the point where an h can be factored out. It's not beautifully pretty, but we're going to expand and simplify and just trust that we'll have an h that's factorable towards the end. All right, so I would probably do the next bit on scrap paper off to the side, but this portion, well, write the easy bits. Lim h approaches 0, take x cubed over h, x plus h, root x plus h, plus x root x. The more difficult part is, what's that? Well, that here. Now, you guys may recognize that as x plus h to the power of 3, because there's a squared lot, and then another power of 1 there. And if you're feeling really fancy, you can do binomial expansion here. So that's part of the reason we did in year 11, so you have it as a trick up your sleeve. And binomial expansion looks like this. X to the 3 plus 3x squared h plus 3xh squared plus h to the power of 3. If that doesn't seem very much fun, the other way to do it is to do FOIL and then FOIL again. So foiling this first one, x plus h squared is going to be x squared plus 2xh plus h squared. And then all of that gets multiplied by another x plus h. So you would do x squared times x is x cubed. X squared times h is plus x squared h. Then here you do 2xh, so times x, which is plus 2x squared h. Then you do it times h, plus 2xh squared, and then the h squared comes in, plus h squared x plus h cubed. Then when you collect all the terms together, you get x cubed plus, well, there's an x squared there, and then there's 2x squareds here, so 3x squared h. Then you have that and that together, because they're both the h squared, so plus 3xh squared plus h cubed, and you end up back here anyway. But that is our top portion, so that's what goes here. X cubed minus 3x squared h. Sorry, why minus? Plus 3xh squared plus h cubed. Alright, didn't leave myself a lot of space. Now, the really nice thing is that x cubed cancels with that one, because it's subtracted off the end. And what you should notice on the here, because it's what we've been hunting, is that every single term remaining on the top has an h as part of it. So I'm going to factor out h, and that leaves me with 3x squared plus 3x plus, 3xh plus h squared. So I've pulled an h out of every term in there to factor it out. Nice. And then that all goes over the top of h bracket x plus h root x plus h plus x root x. All right. So now we finally achieved our goal, which is the next set of marks, is being able to cancel that common factor of h. And certainly we don't see where the whole thing is going yet, but it's a matter of trust. As soon as you cancel that h, you can then let h go towards 0. So at this point here, we're letting h go towards 0, and then f dash x is 3x squared on the top. This, because there's an h in it, will go towards 0. This, because there's an h in it, will go towards 0. Over, now let's see what's happening on the bottom. This is really x times root x, because the h's go to 0, plus x times root x. So both those h's go towards 0. I'm circling them because it makes it look like zeros to me. So x multiplied by root x, 0. Great. Now on the bottom, those are like terms, so we can add them together. 3x squared over 2x root x. Now this is looking more interesting, so let's keep going. 3x squared over 2x to the power of 3 on 2. Because this is a power of 1, this is really a little power of a half. 1 plus a half is 3 on 2. Alright. Then if there's a squared on the top and there's 1.5 on the bottom, really this is 3 on 2 x to the half. Because that 2 minus that 3 on 2 gives us that half. And that is exactly the answer we were hunting for. And I recognize that I've been talking for 20 minutes now, so you're probably exhausted. And these are an intimidating amount of algebra. But it's a practice makes perfect thing. And as you'll see from the past exam questions, these are feasibly the questions they could ask you. So the goal with surds is you're miserable and you want to get rid of them. And you multiply by 1. That's for 1. And you do it using the conjugate. So whatever the sign is here, and the sign will always be negative here because it's negative in the formula, you use a positive sign there. And then on the bottom as well. Don't worry about expanding the bottom. You like the fact there's an h out there already. Then slog through the top, knowing that you will eventually get to this point where you can cancel the h. After you've done that, all the other h's go to 0, and it gets suddenly nicer. So that's the strategy with surds. Alright, last one. Feel free to go grab a drink of water and pause me. But last one is when you have both fractions and surds. And these are relatively rare in exams, but they're mean. And you can expect quite a lot of working. Alright, so the general advice is kiss and cry. Then after that, we're going to get rid of the surds. So multiply by a conjugate to get rid of them. After that, we get rid of the fraction. After that, we cancel out the h and let the remaining h's go to 0, and we'll get our answer. This is effectively like following an essay plan. Once you've got an essay planned out, you then write the essay following the plan. It sounds strange, but this is getting to the point where the maths goes for so long, you need to be following a plan, otherwise you'll just get lost. So our plan is surd first, then deal with the fraction, then cancel the h, remaining h's go to 0, and we should have our answer. Alright, so let's see how we go. First thing, of course, is actually just find the answer. So this is really f of x is equal to 2 root x, which gives me f dash x is equal to x to the minus a half. Because that's 1/2. Half goes down, multiplies by the 2, gives me 1. Power drops, so it's all I'm looking for is that, which might also come up as 1 on root x. So that is my final answer. Alright, so solving this, I would say that f dash x is equal to limit as h approaches 0 of f of x plus h, take f of x over h. Almost forgot that second bit. Now substitute in. So limit as h approaches 0 of 2 over root x plus h, take 2 over root x over h. Alright. Now, our plan was to get rid of the surds. So, in this case, we're using that a plus b, a take b, multiplying by 1, and whatever we do to the top, we do to the bottom. So, our next step is to multiply by 2 on root x plus h plus 2 on root x over 2 on x plus h root plus 2 on root x. Alright, so if it helps in your head, you can think of this one as the a and this one as the b, and therefore what you're ending up with is a squared take b squared on the top. On the bottom, the h is just going to hang at the front. Alright, so lim as h approaches 0. A squared take b squared. Alright, so the first one squared is going to be 4 over x plus h. Take the second one squared is 4 over x. I'm hoping you're happy. You see, if this all gets squared, the top gets squared to 4, the bottom gets squared again, and the root is there. All right. Over h bracket 2 on x plus h with the square root plus 2 on root x closed. All right. So the thirds on the top are gone. Cool. We don't care what the bottom looks like. It can be a bit ugly. Second part of the plan. So we've done this. We've done this. As in we've conjugated and got rid of the thirds. Next step, get rid of the fractions. All right, so we get rid of the fractions by combining these two here. All right, so we're aiming for a common denominator. What I'm going to do now is multiply by 1. And the one I'm going for in this case is x on x. And in this case is x plus h on x plus h. That will get me a common denominator. Then let's rewrite the line after that. Lim h approaches 0 on is 4x over x plus h minus 4x plus h over x plus h over h bracket 2 on root x plus h plus 2 on root x. Close. Whew. All right. Now, combine those on top. They've got a common denominator, so they can be combined. Lim h approaches 0 of, well, 4x minus, and I might expand this one out while we're here. So that's going to be 4x minus 4h over x plus h over, so that's me combining that pair together, is actually that, over h bracket 2 on root x plus h plus 2 on root x. All right, now on the top, clearly, there you go, because 4x is nothing. Now, what's nice is that h, I hope you see my cursor hovering, that h is a factor of the top and can be cancelled with h on the bottom. So that goes and that goes. Now what we're left with is the limit as h goes towards 0 of minus 4h over 2 on root x plus h plus 2 on root x. Woo! No, I missed a whole bit, didn't I? I missed that bit there. Apologies. Still in holiday mode. X plus h over 2 on x plus h with the root plus 2 on root x. All right, so we've cancelled the h out. That's the thing highlighted in green. And what we're left with is that minus 4 on x plus h over that mess. Because we've done that cancel of h, we're not dividing by h anymore. We can let h go towards 0. Let h go towards 0. Gorgeous. So everything here that has an h in it is going towards 0. What we've got is then is f dash x is going to be equal to minus 4 on, well, if that's 0, it's x times x, so x squared, over, now this is 2 on root x plus 2 on root x. Now I have to do a bit of algebraic trickery here. This is equal to minus 4 on x squared on 4 on root x. I'm hoping you're happy that these guys have a common denominator of root x. So 2 on root x plus 2 on root x is 4 on root x. All right, now what I'd like to sort of point out to you is really, this is one fraction divided by another fraction. And you may have learnt this sort of mnemonic in, not mnemonic, memory aid, in middle school, keep, change, flip. So for example, if I have a half divided by 3/4, this is really the same as a half. I keep that, change that to a multiply, and flip this. That is 4 on 6 is 2/3. So I can write a pair of fractions like this, one fraction divided by another, keep the first, change the second, multiply. Sorry, keep the first, change to a multiply, then flip. Keep, change, flip. So that's what I'm going to do here. Minus 4 on x squared, keep that. Change this to a multiply, and flip this. Keep, change, flip. Lovely. Alright. Then, let's put this together. Minus 4 root x over 4x squared. Alright, so let's work that one out. Well, the 4's clearly cancel. That leaves us with minus root x on x squared, which is a half. So there's clearly a negative at the top and the front. There's a half over 2. So half minus 2 is x to the minus 3 on 2. Which is odd. I don't think that's what I wrote in the first place. So let's go up and check. Oh. Yeah, you see, in the classroom, you guys would have yelled at me for this. Because I've just made a very silly error there. This is not actually the same as that. That's a minus a half, which changes everything, because when you differentiate it, that minus a half comes out the front, making it minus 1, and then the minus a half drops down to the minus 3 on 2, which is bang on right. Isn't that weird? I managed to do all the fancy algebra for first principles, but I couldn't even do the shortcut right. Okay. Sorry, that wasn't as smooth as possible, but we're half an hour in, so there's no way I'm re-recording that. Clearly, that should have been at the start of this, but doesn't actually form part of the marks. The marks come from what happened underneath. So marks for this one, this would have been 4 marks. You would have had 1 mark from making the substitution correctly. You would have had 1 mark for probably getting rid of the surds. You'd have had another mark from cancelling the h after combining the fraction, and then your final mark would have come from letting the h disappear to 0 and working your way algebraically down to this. Now, I recognise that was long, but with practice, they do become much smoother. Just strap yourself in and embrace the fact you're going to have to write many lines of algebra. Be careful, and you'll make through it fine. If you get stuck, please send me an email, and I will help you out. Cheers. Bye.